let's dive into something we all use every single second we're online, but maybe don't think about too much: the fundamental rules of the road for the internet. We're talking about IP, TCP, and UDP. Let's get into it. I mean, seriously, have you ever actually stopped to wonder about that? When you send an email or click on a video, how does that data, your data, zip from some server halfway across the planet directly to your screen and not your neighbor's? It feels like magic, but it's not. It's actually a really brilliant system. And that's the whole secret right there. It's not magic, it's just a set of rules, or as they're officially called, protocols. You can think of them as the internet's master logistics plan. It's like a super efficient postal service and a team of the world's strictest traffic cops all rolled into one, making sure billions of little data packets get exactly where they need to go every single second. So let's start at the very beginning with the absolute foundation of this whole system, the address. This is the Internet Protocol, or IP. And trust me, without it, absolutely nothing is going anywhere. Okay, so the Internet Protocol, IP, is huge. Its main job is to give every single device that connects to the internet, your phone, your laptop, your game console, even your smart toaster, a completely unique identifier. That's its IP address. It's basically a digital fingerprint that screams, hey, I'm this specific device and I'm right here on the network. So what does IP actually do? Well, it's got two main gigs. First, it hands out that unique address we just talked about. Then, it acts like a really basic GPS. It stamps your data with a destination address and just sends it off in the right general direction. It's the essential first step, the starting point for any information traveling online. And this analogy is perfect because it gets at a really crucial point. An IP address is just the house number and the street name. It gets the mail truck to the right block, no problem. But it says absolutely nothing about how to handle the package inside. Is it fragile? Does it need a signature? Are all the pieces of the puzzle even in the box? For all that stuff, we need another layer. Okay, so if IP is just the address on the envelope, who's actually making sure the letter gets delivered safely? Well, that's where our reliable delivery service comes in, the Transmission Control Protocol, or TCP. Think of it as IP's very dependable, slightly obsessive partner. TCP's whole mission in life, its entire reason for being, really comes down to two simple words: reliable and ordered. It doesn't just chuck data packets toward a destination and hope for the best. No way. It establishes a formal connection, and then it makes absolutely sure every single piece of data arrives, that it's all intact, and that it's put back together in the correct sequence. So, you might be wondering, how does it actually pull that off? It's this really cool, meticulous three-step process. First, you've got the three-way handshake. That's basically the two devices saying, hey, you there? Yep, I'm here. I can hear you. Great, let's talk. Only then does it start sending data. Next, it numbers every single packet, just like pages in a book, so they can be reassembled perfectly. And finally, it does constant error checking. It's basically asking, hey, did you get page 3? You didn't? Okay, hang on, I'll send it again. It is incredibly thorough. Yeah, that analogy just hits the nail on the head, doesn't it? TCP isn't about just dropping a letter in the mailbox. It's like paying extra for registered mail. You get a receipt when you send it, a tracking number to follow its every move, and you get that final confirmation that it was delivered safely into the right hands. Nothing is left to chance. And believe it or not, you are using TCP all the time, without even thinking about it. Every single time you load a web page, send an email, or download a file, TCP is the silent hero in the background making sure it all works. Because for those tasks, getting the data 100% correct is completely non-negotiable. You can't have a website with half the words missing or download a corrupted file, right? Okay, but what if you don't need that level of perfection? What if perfect accuracy isn't the most important thing? What if what you really, really need is just pure, raw speed? Well, that brings us to our third key protocol, the User Datagram Protocol, or UDP. And UDP is basically the polar opposite of TCP. It's connectionless, which means it doesn't bother with that whole formal handshake thing. It just starts blasting data packets, called datagrams, out into the void. There's no guarantee they'll all arrive, or that they'll arrive in the right order. Its entire philosophy is pretty much fire and forget. So when you put them side by side like this, the trade-off becomes super obvious, right? TCP gives you that rock-solid reliability, but it's slower because of all that checking and confirming. UDP throws all that caution to the wind in exchange for pure, unadulterated speed. So the choice is always between perfection and performance. And this chart really shows you the why behind it all. See that big bar for TCP? That represents all the extra information packed into each data packet. The sequencing numbers, the acknowledgements, the error checking. It's a lot of administrative work, a lot of overhead. UDP's header, on the other hand, is tiny and simple, so it can just send more of the actual data, more quickly. So where does this speed over perfection thing actually make sense? Well, think about a live video stream, a voice call, or better yet, a fast-paced online game. In a game, if your opponent moves and one tiny packet showing their old position gets lost, who cares? It's pointless to stop the entire game to ask for it again. The very next packet, arriving just milliseconds later, has their new position, which is the only one that matters. You would much rather have a tiny, unnoticeable glitch than a massive, game-breaking lag. Okay, so we've got our address system, IP, we've got our registered mail service, TCP, and we've got our speedy postcard service, UDP. Let's pull all these pieces together and see how they create the internet experience we all know. This table just lays it all out so perfectly. You've got IP. That's the fundamental address that every single packet has to have. Then, once the address is on there, the system has to pick its delivery method. Does this situation call for the guaranteed signed-for delivery of a TCP package, or is the fast, no-frills, drop-it-in-the-mailbox approach of a UDP postcard the better call? And that's really the key takeaway here. Every single thing you do online, from loading a page to joining a video call, involves this fundamental decision. IP provides the where, and then either TCP or UDP is chosen to provide the how. It's this constant, invisible choice between perfect accuracy and pure speed, happening millions of times a second all over the world. So that leaves us with a pretty big question to chew on, doesn't it? As we barrel towards a future of real-time AI, the metaverse, and instant global streaming, which of these two philosophies is going to be more important? Is it the slow, steady, reliable builder that is TCP? Or is it the fast, sometimes messy, speedy innovator that is UDP? It's something to think about. Thanks for watching.